What's up, everybody, and welcome back to another video on SAT Math from the Scalar Learning channel. And today we are going over an epic video that is going to help you so much on this test. It is 38 strategies to nail an 800 on the digital SAT Math. Just a quick note before we start, these strategies are based on the College Board Digital SAT Question Bank subcategories. There are 19 of those, so I have 2 strategies per subcategory. Moreover, if you are looking for the best resources to prepare for the digital SAT, look no further than the SAT Crash Course. You can see it up here. Just go to thesatcrashcourse.com and use the code Scalar for 20% off. Again, this is a brand that I've partnered with. I've made video explanations for all of their available 10 tests. They've got new tests being released very shortly. So this is a company that is just on point, creating the best digital SAT content out there. One last thing, if you're looking for ways to grow your mathematic abilities in a fun way, make sure to check out my other channel, Math Puzzles, which the link is in the description below. Strategy number 1, create an equation. And we are in linear equations in one variable. Now, this strategy applies beyond this subcategory, but it's great for linear equations in one variable. Let me show you how we apply it. So it says, Hector used a tool called an auger to remove a storage bin at a constant rate. The bin contained 24,000 bushels of corn when Hector began to use the auger. After 5 hours, of using the auger, 19,350 bushels of corn remain. If the auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when this many bushels of corn remains? So we've got a linear equation word problem, and we've got essentially 2 coordinates. So how can we make an equation from this? Well, we know at 0 hours, we've got 24,000 bushels. We know at 5 hours, we have 19,350 bushels. This is all we need to create an equation for a linear equation, because we can get slope, and we're already given the y-intercept. Now, even when we're not given the y-intercept, we can still make an equation, but this is good to go. All right, so how do we calculate slope? I'm going to use DESMOS. I'm going to use my slope formula. Let's do that now. So we got 24,000 minus 19,350 divided by the respective time values, or x values, 0 minus 5. And then we have our slope of negative 930. Now, we can make an equation. Y equals the slope, negative 930x, plus, what was my y-intercept? My y-intercept was 24,000, because when x was 0, the y value was 24,000. And now I have an equation. Now, coming back to the question, we're trying to figure out when this equals 12,840 bushels. So I'm going to type in on a separate line, y equals 12,840. And now I'm going to look for the intersection of these 2 points. Let's zoom out. So here we have our intersection point of the 2 lines. We've got 12, 12,840, which means the x value is 12 when we have this many bushels. So that's it. D is the winner. Done. Now we're on to strategy number 2, no solution, one solution, or infinite solutions for linear equations in one variable. Now, what am I talking about here? I'm talking about the 3 different ways that we can have a system of equations in terms of the number of solutions. We can't have 2 solutions. Sometimes they show that as an option on the SAT. With the system, you cannot have 2. You can either have none, 1, or infinite. Now, you might say, wait a minute, this is just a singular equation. This is kind of a system of equations that are sort of set equal to each other. It's like this could be one equation and this could be the other one. And the reason why this is important is because this is going to give you a great shortcut. When they say right here, we're trying to find k, right, with an equation that has no solution. What that means is that the slopes of the solution of the 2 equations must be the same, whereas the y-intercepts must be different. And we kind of got a slope here and a y-intercept here. Now, this has a 3 factored out. I'm just going to redistribute this in, and then I've got 3kx plus 39. So they're talking about having no solution. So I should immediately know that these slopes need to be the exact same. Now, the good thing is the y-intercepts, 39 and 36, are already different, so we're set there. So I'm going to set 3k equal to 48 over 17, and then I'm going to isolate k. So I'm going to divide both sides by 3, boom, and divide this by 3. And that will divide the numerator by 3, so 48 divided by 3 is 16. So the answer is 16 over 17, boom, done. Strategy number 3, plug in known values. This is again for linear functions now. Oil and gas production in a certain area dropped from 4 million in 2000 to 1.9 in 2013. Assuming that oil and gas production decreased at a constant rate, which of the following linear functions best models production in millions t years after 2000? So here's the cool part, right? If we're saying t years after 2000, I know when I plug in 0, that's right, in 2000, that'd be 0 years after 2000, I should get 4. I also know that when I plug in 13, right, 13 years after 2000, I should get 1.9. So now I can look through these equations and see, all right, for which of these equations when I plug in 0 do I get 4? Okay, that's all of them, right? For every single one, they have a y-intercept of 4, so that's not going to help. But this one should help. I can already eliminate A and B because I know if I plug in 13, it's going to be a positive value plus 4. That's going to be bigger than 4, not 1.9. So now I'm down to do these two options. Let's check it out in Desmos. So here's option C, and let's plug in 13 right here. Check it out. We get the value of 1.9 that we should have gotten for the correct answer, which means C is the winner. Done. Strategy number 4, make a table. Again, this is for linear functions. So check it out. We've got this equation. It says the function f gives a temperature in degrees that corresponds to a temperature of x kelvins. If a temperature increases by 9.1 kelvins, by how much did the temperature increase in Fahrenheit? So check this out. I'm going to choose 2 Kelvin values that are 9.1 apart. Arbitrary, it doesn't matter what. So I'm going to start with the easiest values. Now, you might say 0 would be great, but in fact, in this situation, I'm going to argue that an x value of 273.15 is going to be easier because I can do that very quickly mentally, right? I plug that in for x. That minus 273.15, meaning itself, is going to be 0. 0 times 9/5 is 0, plus 32 is 32. Beautiful. Now I'm going to increase this by 9.1, so I've got 282.25. I'm even able to do that nicely and mentally. And then I'm going to plug that in here. Well, since I know that this is 9.1 greater than this value, the difference is going to be a nice 9.1. Now I'll finish it off in Desmos. 9/5 times 9.1 plus 32 is 48.38. And these are the Fahrenheit values, so now I just got to look, how much did it go up by? It went up by 16.38, which means A is the winner. Done. Last thing I'll say about this table strategy, it's not only amazing for linear functions, it's incredible for exponential functions as well. Strategy number 5, start with slope-intercept form. This is for linear equations in 2 variables. So it says the graph of the equation here lies in a plane where a and k are constants. If the line contains these 2 points, what is the value of k? So the first thing I'm going to do is put this into slope-intercept form. And this is a great thing to do with a lot of linear equation problems, and you're going to see why. So first, let's isolate y. That's how we put it into slope-intercept form. ky equals negative ax plus 6. Then I'm going to divide both sides by k. And I've got y equals negative a over k x plus 6 over k. So I've got some really cool things here. First of all, I've got this part, which is my slope, but I don't really care about slope. All I care about is k. And the reason why this is awesome is because 6 over k right here is my y-intercept. Why is that especially awesome for this problem? They give us the y-intercept. So don't forget, as long as the x value is 0, this is your y-intercept coordinate, which means that 6 over k must equal that y-intercept value of negative 3. Now I've got a really nice equation. Let's solve. Multiply it both sides by k, divide both sides by negative 3. I'm kind of doing it quickly here, but we got 6 over negative 3, therefore equals k, which means 6 over negative 3 is negative 2. A is the winner. Done. Strategy number 6, use x and y intercepts. Okay, so check this out. We're again still in linear equations in 2 variables. The points plotted in the coordinate plane above represent the possible numbers of wallflowers and cornflowers that someone can buy at the garden store in order to spend exactly $24. So this is the fixed spend, right? On 2 types of flowers. The price of each wallflower is the same and the price of each cornflower is the same. What is the price in dollars of one cornflower? These types of problems, especially with these graphs where we've got a set price, we've got different quantities of each of these, whatever the items are, the x and y intercepts are super valuable. Now, I'm going to show you why. If they're talking about the price of one cornflower, if I use this intercept, right, where we're using exactly 16 cornflowers, and that would be 0 wallflowers because the intercept one or the other has to be 0, right? I now know that 16 cornflowers must cost $24. So I'm not dealing with cornflowers and wallflowers because all I care about is cornflowers. So now I know 16, because that's a quantity, times the price of one corn flour, which is unknown, equals 24. Got an equation, now I can solve. Divide both sides by 16, like so. We got 24 divided by 16. Just to give you the decimal equivalent so we have a better understanding in terms of money, it's 1.5, which we would say is $1.50, but you can enter it as 1.5. That's how you do it. Done. Now we're into systems of two linear equations and two variables. And the strategy here, strategy number 7, is look for expression layups. So what am I talking about? Notice what they're asking for. They're asking for 3x plus 3y. They're not asking you to solve for x and y individually, which you can. By the way, you can plug this into DESMOS. You can solve it algebraically. Lots of options. But you don't need to do that. And the College Board will routinely give you what I call layups, meaning if you manipulate these equations or one of these equations correctly, you can solve this very quickly. And that layup is right here. Notice 3x and 3y, these are 3 apart, so are these. So there's something going on here. Now watch this. If I just simply multiply the denominator by -1, I go negative, positive, negative. By the way, don't do what I'm doing on the real test where you actually manipulate, something like your core base formula that you've written down. Now we can just add these equations together. Watch this. 7x minus 4x is 3x. Negative 5y plus 8y is 3y. Look at that. We got the expression that we're trying to solve for. Equals, what's 4 minus 9? That is -5. And we got our answer. We didn't have to solve for x or y individually. Saves so much time, which means B is the winner. Done. Strategy number 8, extract numbers. This is still in systems of two linear equations and two variables. So check this out. We've got this word problem. A movie theater sells 2 types of tickets. Adult for 12 and children for 8. So watch what I'm going to do. I'm going to write it out like so I can see it in a format that makes sense to me. Now it says if the theater sold 30 tickets total for a total of 300, how much in dollars was spent on adult tickets? All right, now I got all my information where I can make a nice equation. The only thing I'm missing are variables, so let's arbitrarily assign x to children, y to adults, and let's go. So we know that x and y are the number of tickets sold for each of these categories, and we know therefore that since there's 30 tickets sold, x plus y must equal 30. We also know that for the amount of money, we know we're making $8 per child ticket. We know we're getting $12 per adult ticket, and the total amount of money we're making is $300. Now we've got this beautiful equation, and now we can start to solve for y. But just be careful, right? Because they're not asking the number of adult tickets sold. They're saying how much was spent on adult tickets. So what are we really looking for? We're actually looking for 12 times y, right? The number of adult tickets times the cost per ticket, which is $12. But anyways, let's plug this into DESMOS and first solve for y. So now we see these intersect at 15, 15. So both are 15. So now I know that y equals 15. Again, we're not trying to get the y itself. We're trying to get 12 times y. So 12 times 15, I'll do that mentally, is 180. And just to verify my answer, make sure to do this as well on the SAT. If that is 15, is 15 for children as well. What's 8 times 15? That's 120. And they do add up to 300. So this means that my answer is verified. 180 is the winner. Done. Strategy number 9, set up inequality as you read, and this is linear inequalities in 1 or 2 variables. So watch what I do, and this is what I do in real time on the test. A number x is at most, when we say at most, that means less than or equal to. Think about it. If you say, hey, you have at most $100, that means you have 100 or less. You could have 99, 98, 80, 50, etc. So think about it that way if you're ever stuck on what does that mean in terms of an inequality. So x is at most 2 less than 3 times the value of y. Now it says if the value of y is the verb is often equal, is -4. What is the greatest possible value of x? Now I get everything I need. I can just plug and chug, right? 3 times -4 is -12 minus 2. And x is less than or equal to that. -12 minus 2 is -14. And now we can find the greatest possible value. So again, x is less than or equal to -14. It could be -14, -15, -16, etc. down to -infinity. So the greatest possible value is this right here. -14 for the win. Done. Strategy number 10, DESMOS, right? DESMOS is available throughout the entire test. One thing I do want to caution all of you guys is don't overuse it. There are times on this test where you don't want to just jump straight to DESMOS and start using the sliders. Sometimes that can take you down the wrong path. but it's an amazing tool. And you notice in a lot of these previous strategies, I've been weaving DESMOS in to my problem solving process. So anyways, but with these inequalities, it's going to be really powerful. So check this out. Which of the following consists of the y coordinates of all points that satisfy the system of inequalities above? I'm going to plug this into DESMOS straight away, and then we're going to analyze it. So systems of inequalities, DESMOS is really great with these because you can see the solution set is the double shaded region, right? So it's this section right here. Now they're saying which of the following consists of the y coordinates of all these points, right? So basically what they're saying is, are the solutions all going to have y's greater than 6, greater than 4, greater than 2.5, or 1.5? Now let's go back to the graph. We can see that they intersect right here at 2.5 comma 4. So 4 is the intersection point, but it's not everything at 4, right? Because these are dotted lines. So we're not including 4, but everything above 4. All the y values in this region are going to be above 4. And look at that. They have that answer right here. Option B. B is the winner. Done. Strategy number 11, know your exponent rules. And this one in particular is about anything going to the 0th power equaling 1. So that's the key here. So let's check this out. The given function f models the number of advertisements a company sent to its clients each year, where x represents the number of years since 1997, and x is between 0 and 5. So again, 0 is going to represent the year 1997. Which of the following is the best interpretation of the y-intercept? So again, as I mentioned, even in the linear equations, the same thing here. The y-intercept occurs when x is equal to 0. So we don't even need to use any calculator, anything like that. We can do this all mentally because I can plug this in straight away. And as I mentioned before, anything to the 0th power is 1. So that's just going to go away to 1. 1 times 9,000 is 9,000. So at least now I've actually found my y-intercept. So I need 9,000 in the answer. A and C, talking about 1708, therefore, are out. So now it's down to B and D. Now, the other thing we need to know is what is the y-intercept? Y-intercept, I don't care if you're talking about linear, exponential, quadratic, y-intercept is my initial value. That's how you want to think about it. Now, the initial value here is going to be the value in 1997, right? Because they're saying years since 1997. So this has nothing to do with being a minimum, but it does have something to do with the value in 1997, which means D is the winner. Done. Strategy number 12, utilize symmetry of x-intercepts. This is so important, especially for really high-level quadratic problems. So check this out. The quadratic function h is defined as shown. In the xy plane, the graph of y equals h of x intersects the x-axis at points 0, 0, and t0, where t is a constant. What is the value of t? Now, first of all, this is in vertex form, which is also important to know because the vertex, it can be found just by saying, oh, the negative x value of the vertex is right here. So if that is -4, my x value of the vertex is +4. And my y value, not that we really need it here, but it's -32. So I'm just going to write that out. And since we know now that the vertex is at 4, -32, and we know that one of the x-intercepts is at 0, 0, the other one must be equidistant to the vertex, right? So this one right here is 4 away to the left. The other one must be 4 to the right, meaning it's going to be at 8, 0. Therefore, t is 8. Now, of course, this one can be done in DESMOS, right? We can plug it straight into DESMOS, and I'll show you that now. So here it is in DESMOS, and again, we see that vertex that I did predict, and we can immediately see the x-intercept. In certain cases, this is definitely going to be faster. I would argue that in this question, this might have been a faster strategy, but there are going to be other question types where you can't just plug it straight in. It's going to be much more abstract. So knowing the symmetry property of the x-intercepts, actually really any coordinate around the axis of symmetry or the vertex in particular, is going to be very helpful. Strategy number 13, the number of solutions means discriminant. Now, what am I talking about? I'm not talking about linear equations. I'm talking about quadratics, right? And this is nonlinear equations in one variable and systems of equations in two variables, okay? So nonlinear, that's quadratics, that's exponential, etc. In the xy plane, a line with the equation 2y equals 4.5 intersects a parabola at exactly 1 point. This means a system where we have one intersection point, aka one solution. If the parabola has equation this, where b is a positive constant, what is the value of b? So first of all, let's get a singular equation solving for the system. So if I know that 2y equals 4.5, divide both sides by 2, y equals 2.25. Now, since this is a system of equations, let's plug this in for y down here and rewrite it. So now we got this great equation, and again, it's a quadratic equation because the highest degree is 2. Let's set everything now equal to 0. So all I'm doing is I'm minusing 2.25 from both sides. And now we have a quadratic. Now, since they're saying we have one solution, that means the discriminant has to equal 0. If we have one solution, the discriminant equals 0. If it's less than 0, we have no solutions, no real solutions. And if it's greater than 0, we have 2 solutions. So this is 2, 1, and none. And what is the discriminant? Just a quick refresher. It is b squared minus 4ac, where a is that coefficient of x squared, b is the coefficient of x, and c is that standalone constant. So here we go. B is literally b here, so b squared minus 4, a is negative 4, and c is negative 2.25. And of course, since we're trying to get one solution, this needs to equal 0. Now we can do this in DESMOS. I'm going to do it mentally just for fun. So negative 4 times negative 2.25, that's 8 plus 1 is 9, positive 9. And then 9 times negative 4 is negative 36. So b squared minus 36 is equal to 0. Add 36 to both sides. B squared equals 36. Take the square root, and b equals plus or minus 6. Now again, since I said b is a positive constant, we're going to take the positive version of this, which is 6, which means 6 is the winner. Done. Strategy number 14, pay attention to final part of questions. What am I talking about? I'm talking about this part right here. It says if x is a solution to the given equation, which of the following is a possible value of x plus 5? We're not solving for x, and I guarantee you one of these answer choices is the value of x. Now for this one here, I would say the fastest way to do this is probably just to plug it straight into DESMOS, so we're going to do that now. So the nice thing about equations is you can plug them straight in, and you've got the solution or solutions appearing as these straight lines. We just have to identify where these straight lines land, and they land at negative 4.5 and negative 5.5. Now again, I don't want x, right? I want x plus 5. So here we go, negative 4.5 plus 5 and negative 5.5 plus 5. We got two solutions, positive 1/2 and negative 1/2. The only one they provide is positive 1/2, and that's how you do it. But by the way, they did have 4.5 and 5.5 right here. Now granted, in my solution, they were both negative. Here they're positive, so that could have been a telltale that these are wrong, but it could have tripped you up, so something to be mindful of. Strategy number 15, FOIL or factor when stuck. So sometimes I look at an equation like this, especially for equivalent expressions, and I say, all right, let me get this one to look like the one on the right-hand side. And the way I'm going to do that is I'm going to FOIL it out, and then we can match up like terms to solve for these missing constants. So it's going to work really nicely here. And again, we're trying to solve for the value of a times b, the product of a and b. So we need to solve for a and b. So let's check this out. I'm going to distribute here, here, and here. So that's going to give me 5ax cubed, right? Then ax times that is negative abx squared. And then ax times 4 is 4ax. And watch how I stack it. Now that I distribute the 3, we go bop, 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 and I'm going to put the like terms right underneath each other, right? 3 times 5x squared is 15x squared, so I'm going to put it under here. 3 times negative bx is negative 3bx, and then 3 times 4 is 12. These are equivalent, right, because of the equal sign, so that makes sense that I got 12 equaling 12. Now, I know that these are going to match, and I also know that these are going to match, and so on and so forth. But right here, I've actually already got enough. And by the way, I don't even need to solve for a individually, even though I can quite easily. I can see that 5 times a has to equal 20, so a is 4. But with the red terms, I've got enough because all I need to do is solve for the product of a, b, and they've got a times b right here. So check this out. I'm going to set all the x squared terms equal to each other and simply isolate for negative ab. So I'm going to minus 15x squared from both sides. So negative 9 minus 15 is negative 24x squared, and that equals negative abx squared. Now, I don't care about the x squareds. I can divide by them and get rid of them. Negative ab equals negative 24, which means multiply both sides by negative 1. AB equals 24. C is the winner. Done. Strategy 16, know your exponent to radical conversions. Now, again, this is equivalent expressions, but this is kind of a exponent equivalent expressions hybrid, if you will. So how do I get this to look like that? Well, first of all, I see this is in rational form. This is in radical form. So I want to start off by just immediately putting these in the same form. And I know I'm trying to solve for a over b, so let's get the radical to the rational format. So when I say square root of x to the 5th, the way that I convert that is the power is the numerator, and the index of this radical, which is 2 when it's invisible, right? That goes on as the denominator. So we got x to the 5 over 2 over, and then same process there, x to the 4 over, the index is 3, 4/3. And this equals x to the a over b. Now again, knowing my exponent rules, right? We know that when we've got a quotient, we subtract the exponent. So I know that now I can consolidate these two and say it's x to the 5 over 2 minus 4 over 3. And this is going to straight away equal x to the a over b. So since I'm just trying to solve for a over b, all I got to do is figure out what this difference is, and that's a over b. Let's get some nice common denominators. Multiply by 2, multiply by 3 and 3. So I got 15 over 6 minus 8 over 6. 15 minus 8 is, of course, 7. So my final answer is 7 over 6. That's how you do it. Done. Strategy number 17, use arithmetic when it's easy. So check this out. Jeremy deposited X dollars in his investment account on January 1st, 2001. The amount of money in the account doubled each year until Jeremy had $480 in his investment on 2005. What is the value of X? And again, that's the value put in 2001. So could I make an exponential equation? Could I plug in values like that? Yeah, of course I could, but you know, this is a relatively easy operation that you can even do mentally. I'm not even going to use DESMOS. So check this out. If it's doubling going forward, what is it doing going backwards? It's halving, right? So watch this. I can just rewind the clock. 480 divided by 2 is 240. Divided by 2 is 120. Divided by 2 is 60. Divided by 2 is 30. And so X is what we got here, which means 30 is the winner. Done. Strategy number 18, substitute, good old-fashioned substitution, and it's going to be especially useful for this crazy abstract problem like we have here. Also, when these numbers are really weird like this, like sometimes I say, hey, just pick numbers for A and B. That's going to be pretty hard with these weird numbers, but check this out. We got basically a system of two equations. I mean, that's really what this is, even though it's under ratios, rates, and proportions. So check this out. What I'm going to do first is I'm going to see which one of these is going to be easier to isolate a variable. I'm going to actually say this equation is going to be easier to isolate. I can isolate A because I got A over Bn equals 26.8. If I multiply both sides by Bn, I've got A equals 26.8 Bn, like so. Now I can sub this in right there. So now I've got 4, and instead of A, I'm going to plug in 26.8 Bn over B is equal to 6.7. Now I'm trying to solve for n. Well, the nice thing about this is the b's are going to cancel out like so. 4 times 26.8, I'm going to use DESMOS, and I got 107.2. So now I've got 107.2, that's that, with a little n there is equal to 6.7. Last but not least, I got to isolate n. So I'm going to divide both sides by 107.2. So n equals 6.7 over 107.2. Of course, we can't fit that in to the SAT free response section. So let's see what that reduces to. And we've got this decimal. Oh, another little nifty trick. If I want to convert this to a fraction, click this button and I've got 1 over 16. So the fraction answer is 1 over 16. That's how you do it. Done. Strategy number 19, percent of versus percent increase. You got to know the difference. So now we're in percentages. Now it says the number of A is 70% less than the positive number B. It's not saying 70% of, and I know I said percent increase, this is a percent decrease, but it's that same idea. 70% less than the positive number B. So we don't want to do something like this. When I take 70% away, you want to think what's remaining. If I remove 70%, I've got 30%. So the number A is 30% of B. The number C is 80% greater. Again, it's not 80% of, 80% greater means it's equal to A plus another 80% of A, aka 1.8 times A. Now we've got our correct system. Last but not least, it's saying the number C is how many times B, meaning we need an equation relating just C and B, so we need some substitution in the mix. Well, I know that A equals 0.3B. Let's plug that in for A right there. So we got C equals 1.8 times 0.3b. Since I know that 3 times 18 is 54, 0.3 times 1.8 is 0.54b. Now it says C is, and there's my equal sign, so that looks good. How many times B? And it's right there, 0.54. Now, just a quick note, if they would have said C is what percent of B, you'd have to convert that back to a percentage, which would be 54 without a decimal point. But anyways, 0.54 is the winner. Done. Strategy number 20, know your percent of change formula. So check this out. This shows the total amount of snow in inches recorded each year from 2003 to 2015. If P% is the percent decrease in the annual snowfall from here to here, what is the value of P? All right, let's write these values down. So in 2003, it was 40. In 2007, it was 10. So watch how I do this. I say from 40 to 10, how much did it change? It went down by 30. And if I want to know the percent decrease from here to here, I take this change value as a percent of 40, meaning 30 out of 40. Now, this is going to give me a decimal value. I don't need to use decimals. I know that this is 0.75. But if we're talking about P as a percent, we do the decimal conversion, aka bump the decimal over twice. And we've got 75% for the win. We just say 75, boom, done. Strategy number 21, know your DESMOS mean function. There's also a median function as well. So check this out. Andrew and Maria each collected 6 rocks, and the mass of the rocks are shown. The mean of the masses is 0.1 kilograms for Maria, greater than the mean of Andrew's. So Andrew's would just be mean. Hers is 0.1 plus mean. What is the value of X? So we're trying to find this missing value to give me 0.1 higher. So first of all, we need to know what is the mean of Andrew's. Now, there is another little tiny shortcut. You know that if there's 6 values in each, to have a mean that is 0.1 greater, we need a total that is 6 times 0.1 greater, aka 0.6 greater. So I could just look at the totals, but let's not get fancy. Let's just do the actual mean calculation because it's so easy in Desmos. So check this out. So now I've got both of the means written out with the data. Of course, I've got a constant here, a constant variable as a slider, which I can adjust to get the right value. So again, I've immediately got the calculation for the mean of the top table. You just have to make absolutely certain that you don't have a typo, right? So I double check, triple check that all the values are correct, and we get this nice mean of 2.8. Now, as I mentioned before, this needs to be 2.9. So right now it's at 2.633. So we can kind of adjust the slider until we get around 2.9. And you can see that hits right at 2.6, which means the value of X is simply 2.6. That's how you do it. Done. Strategy number 22, understand mean, median, and standard deviation. So this is beyond just simply using a calculator. What is mean? What is median? What is standard deviation? Again, mean is the average, right? We add everything up and divide by the total number. Median is the middle value when the values are arranged from least to greatest. And standard deviation, we don't have to know how to calculate it. You just have to know roughly that this is the spread of the data, right? If it's more spread away from the mean or the center, then it's got a greater standard deviation. If the values are more tightly compacted near the center, near the mean, then it's got a smaller standard deviation. Now let's read the question. It says a data set of 27 numbers has a mean of 33 and a median of 33. A new data set is created by adding 7 to each number in the original data set that is greater than the median and subtracting 7 from each number in the original data set that is less than the median. Which of the following measures does not have the same value in both sets? So now in the first one, we know we have that nice center of 33 and 33 for the mean and the median, and then we've got all the values to the left and to the right. And since median is the exact middle and there's 27 values, we're going to have 13 here and 13 here. Now I'm just writing that out to give you context. In the second data set, they're leaving the median alone, and the mean's going to stay the same, but I'm going to tell you why in a second. And then these 13, we're going to go minus 7. These 13, we're going to add 7. So what you can immediately see, right? If I'm minusing 7 from these 13 and adding 7 to these 13, that's a net negative 91 and net positive 91 that's going to be added to the total. Those are going to cancel out. So that means the mean is not going to change. Also, the median is not going to change because these values are still going to be below the median. These are still going to be above the median. The median is the middle. The middle is not going to change. The median is not going to change. And again, since the mean doesn't change, the sum of the numbers can't change either because the mean comes from the sum, right? We take the sum and we divide it by 27. Now, why is D the answer? Well, again, I said D is all about the spread away from the center. Well, these values are all being shifted to the left. They're getting farther away from the center. These values are all being shifted to the right, again, away from the center. So we're increasing the spread. Understanding what standard deviation is, not knowing just how to calculate it, but understanding what it is key here. So D is the winner. Done. Strategy 23, review graph thoroughly before solving. So don't just jump in. A lot of times people just go, oh, I'm going to go straight to the question. No, really understand this. This is saying, oh, this is sales. So that's sales of 300, 400, etc. And this is temperature in C. But again, notice, and this is the important part, we're not starting at 0, 0. We're not starting at the origin. We're starting at 300, and we're starting at 10. That's very important because sometimes people say, oh, the y-intercept looks like it's about 400, except that's not the y-axis. So that's why looking at the graph, especially for these high-level difficulty problems, is going to be key. So it says the scatter plot shows the company's ice cream sales in D dollars and the high temperature T, which is right here, right? And this is D dollars. On 12 different days, a line of best fit is shown. Which of the following could be an equation of the line of best fit? So again, if you've mistakenly said, hey, my y-intercept is around 400, you'd be zoning into these two. But that's incorrect. A and B are actually wrong. So how do you actually go ahead and solve one of these problems? Well, the safest bet in terms of trying to create an equation of a line, especially for something like this, is just pick 2 coordinates, okay? So I'm going to try and get 2 nice coordinates that are closest to these crosshairs as possible. Let's try this one. That is an x value of 22 and a y value of about 800. It's not perfect, but it's close. And then we've also got, let's say, if I extended this line, let's say right here, we've got about 10, 400. Now I can very easily calculate the slope just by taking the difference of the y's, 800 minus 400, which is 400, over 22 minus 10, which is 12. So this gives me slope, and that's not going to help tremendously because both of these have the same slope, but at least I know, all right, 400 divided by 12, it's probably about 33. Now the next thing I can do is come up with the equation using point slope. These are both legitimate points, so let's go for it. We've got D minus that D value, 400, is equal to my slope, and I'm going to take 33, even though 400 over 12 is 33.33333. I'm going to use these values because that's what they provided, and I know it's got to be 33 because I've eliminated these two already. 33 times T minus 10. And now all I got to do is isolate D, and I'll get one of these two. Distribute. We've got 33t minus 330. Last but not least, let's add 400 to both sides. D equals 33t. 400 plus negative 330 is positive 70. All right, not super close to 84, but clearly way closer to 84 than 300. So we can definitively say D is the winner. Done. Strategy number 24 for these scatter plots is visualize the line of best fit. Now, I know you won't be able to draw in a line of best fit like I'm going to do right now, but try and visualize it. And again, the way I like to think about lines of best fit is like threading the needle, right? We're trying to kind of get it right through the center of all this data. It's not perfect, but something like this. Now it's asking which of these could be the equation, right? Which of these could be the equation for the line of best fit. Now, when I look at this, I can see that my y-intercept, because this is the y-axis, is somewhere around here, right? Maybe 90, 80, something like that. But I know it's not 0. I can say that definitively. So it can't be D, right? D has no y-intercept. Now it's one of these 3. And what's different about all of them is they all have different slopes. It's either 200, 100, or 500. So again, the way that I'm going to look at this is I'm going to choose 2 points and just calculate the slope from my purported line of best fit. So here we've got 3, 400, and here we've got 0, and I'm going to use 100, even though my graph, it looks maybe a little less than 100, but they all have 100, so I'm going to use that. Now we're going to calculate the slope. 400 minus 100 is 300 over 3 minus 0, and we get a y-intercept, and we get a slope of 100, which means B is the winner. Done. Strategy number 25, identify the relevant numbers. This is especially useful in a crazy word problem like this. So watch what I'm going to do. I'm going to underline everything. In May 10th, 2015, I am going to underline the date. We've got 83 million subscribers. The majority of internet providers are blah, 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 these companies. But, those names aren't as relevant as the numbers. And then it says by September 30th, the number of internet subscribers had increased to 97 million. Now I'm going to extract these numbers and write them out. If an internet subscriber in Nigeria in September 30th is selected at random, the probability that the person selected was an MTN subscriber is 0.43. There were P million MTN subscribers in Nigeria on September 30th. To the nearest integer, what is P? Now that we have all the numbers written out, we can figure out what we have to do here. And since they're not talking about an increase, they're not talking about a change, they're saying that all we really care about is this September 30th date. We don't really have to pay attention to this, but I still wanted to extract it to get my head around the problem first before I just dismissed it outright. Now to get P, what we do is, if this is the probability, this is kind of saying this is the percent, right? So really I'm taking 43%, aka multiplying 0.43 times 97, and that's going to give me my p-value. So 0.43 times 97 is 41.71. They said the nearest integer is rounded up to 42. So there were 42 million MTN subscribers in September, which means 42 is the winner. Done. Strategy number 26, get familiar with conditional language. Okay, this is a conditional probability question. So we got this table, 90 participants says, one of these participants will be selected at random. What is the probability of selecting a participant from group A given that the participant is at least 10 years of age? So when they say given like that, that's the condition, right? So they're saying we're only looking at the subset where they're at least 10 years old, meaning we're looking only at this region right here. So now we want to know what's the probability that we're in this bucket when this is kind of our total, right? So we can say, well, 10 to 19, we've got 30, 20 plus, we've got 30. So my actual total of 10 or older is 30 plus 30, which is 60. And then what's the probability that we're in group A? 14 plus 9, that's the number in group A, which is 23, which means the answer is 23 out of 60. That's how you do it. Done. Strategy number 27, immediately calculate margin. This is for margin of error. So let me show you how this works. In a study of cell phone use, 799 randomly selected U.S. teens were asked how often they talk on the cell phone and their texting behavior. The data summarized in the table above, based on the data from the study, an estimate of the percent of U.S. teens who are heavy texters is 30% with a margin of error of 3. So immediately, I'm going to say, oh, so if it's a margin of error of 3 at 30%, I'm going to go minus 3, 27, plus 3, 33. And this is my margin, anywhere from 27% to 33%. And I'd say 8 times out of 10, the answer choice, the correct one anyways, is going to have something to do with 27 to 33. Now, as we scroll down here, we can see that these choices have something to do with this margin. So first it says approximately 3% of the teens are not really heavy texters. That's not how we use margin of error. This is how we use margin of error. So I say A doesn't make sense. It is not possible that the percent will be less than 27. So that's not what our margin of error means. And again, be careful about these really definitive statements. It's not possible. It must be, etc. It could be less than 27. It could be greater than 33, but it's plausible. It's highly likely that it's within 27 to 33. So I'm going to get rid of B. And again, the percent of all U.S. teens who are heavy texters is 33%. That's so definitive. Goodbye. Now, usually what we'd see in a good answer is it is plausible, right, that the number of heavy texters is like between 27 and 33. They don't have that. But instead, they say it is doubtful. Now, they don't say it is impossible, but they say it is unlikely or doubtful that it is 35%. Why? Because it's outside of this margin that we've calculated, which means D is the winner. Done. Strategy number 28, pay close attention to quantitative language. Let's check this out. In State X, Mr. Camp's 8th grade class consisting of 26 students were surveyed and 34.6% of students reported that they had at least 2 siblings. The average 8th grade class in the state is 26. If the students in Mr. Camp's class are representative students in the state's 8th grade classes, and there are 1,800 classes, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? This is the key. This is the quantitative language that we have to watch out for. Now, this is, again, all these questions are high difficulty, but this is the trick, right? Because with this important percentage, this is at least 2 siblings. Fewer than 2 siblings is not this. It's everything but this, right? This is greater than or equal to 2. If I want less than 2, it's going to be the remainder. So it's 100 minus this, which I can do mentally, right, is 65.4%. If you miss this little detail, you're hosed. You're going to get this question wrong. So be very mindful of that quantitative language. So now we have all the information we need to do this calculation because we know the average class size is 26. And since there are 1,800 classes, we can multiply these two together to get our estimate of the total number of 8th graders in the state. And then of this, we're taking 65.4%. So let's do this in DESMOS. And we get approximately 30,607. And the closest to that is C. So C is the winner. Done. Strategy number 29, understand samples and population. So this is for evaluating statistical claims. And it says a psychologist designed and conducted a study to determine whether playing a certain educational game increases middle school students' accuracy in adding fractions. For the study, the psychologist chose a random sample of 35 students from all of the students in one of the middle schools in a large city. Very important. The psychologist found that students who played the game showed significant improvement in accuracy when adding fractions. What is the largest group to which the results of the study can be generalized? Now, this is all about where you get your random sample from, right? If you randomly sample the entire United States, even if you only take 100 people or 1,000 people, you can apply those results to the entire population of the United States. But if your random sample is specifically targeted to, let's say, Los Angeles, you randomly sample 1,000 people in Los Angeles, then those results can only be applied to the population of Los Angeles. So since this random sample, don't worry about the 35, but the fact that the random sample was taken from students in one middle school, the results can only be applied to all the students in that one middle school. So 35 students in the sample, that's obviously too small. We can't apply it to all the students in the city because it wasn't a random sample of all the students in the city. And we can't apply it to all middle schools either. This was only taken at one middle school, which means B is the winner. Done. Strategy number 30, watch out for overly definitive statements. I've already touched upon this in a previous question, but let's hit it again. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. Again, the random sample is being taken at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Now, I can already tell you, right, there's got to be a bias here. This is clearly not a correct random sample. It's biased because, like, if you're going to go to a playground, everybody there probably has kids, right? But anyways, let's look at option A. It says the mean number of children per household is 2.4. So definitive, too definitive, out. Now, the rest of these has to do with whether this sampling method is flawed or not flawed. I've already touched upon that. It's definitely flawed, so we can eliminate D. And it's not because the sample size is actually too small. It's because of where the sampling was done. So it's going to be option C. The sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. It doesn't say why, but we already identified and we already kind of had that notion that, yeah, it's probably biased because of where they did it. So C is the winner. Done. Strategy number 31, use concrete numbers for abstract problems. So check this out. It says a rectangular poster has an area of 360 square inches. And again, this isn't this strategy in particular, but I touch upon this later. I'm going to draw out a diagram, even though this might seem relatively simple. So they said rectangular poster, I got a rectangle, and it says it has an area of 360. A copy of the poster is made in which the length and width are each increased by 20%. What is the area of the copy in square inches? Now, you could say, all right, this could be X, this could be Y, blah, blah, blah. But this is going to be much easier if you're just like, let me choose arbitrary values for the length and the width. That's going to make it so much easier. How about 10 and 36, right? 10 times 36 gives me an area of 360. Great. Now I'm going to increase each of them by 20%. We can use DESMOS. I'm going to do this mentally just for fun. And again, increased by 20% is the same as multiplying by 20% and adding that to the original, or multiplying by 1.2. So 20% increase. That would be adding on 2 to 10. So it would now be 12. And then 20% of 36 is 7.2. Adding that on would give me 43.2. So now it says, what is the area in square inches of the copy? Well, all I got to do is length times width. This part I'm going to do in DESMOS. And we get 518.4. So 518.4 for the win. Done. And one last quick note, you may be saying, well, hey, you picked 12 and 36. What if you picked 2 and 18 or some other combination, right? It's actually still going to be the same. Strategy number 32, get familiar with the reference sheet. So here is the SAT reference sheet, and these are all the formulas that are given. So you got to make sure you know what's here so that when they ask a particular question, asking about one of these formulas, etc., you know where you can find it. And it's always accessible on the Blue Book app. Any question, you can just click the button that says reference sheet, boom, it will pop up. So this one says a right circular cone has a volume of 1/3 pi cubic feet and a height of 9 feet. What is the radius? And again, here's my volume formula for a cone. So this is perfect. I'm going to write that down. So there we go. And now we just plug and chug. We know the volume here is this. The height is 9. And we're trying to solve for radius. So let's plug and chug. So now I got 1/3 pi and 1/3 pi on both sides. Divide by 1/3 pi and we get 1 on the left-hand side. And that goes away there because it's just 1. And so we get simply r squared times 9. And now we need to solve for r, right? So I'm going to divide both sides by 9, and I get 1/9 equals r squared. Last but not least, take the square root of both sides. The square root of 1/9 is 1/3, which means A is the winner. Done. Strategy number 33, know your triangle similarity theorem. So it says the area of triangle ABC above is at least 48, but no more than 60. And that's the big dog, right? So it's somewhere between 48 and 60. If y is an integer, what is one possible value of x? So we're trying to solve for x. Now, when I say know your similarity theorems, we need to first know that these two triangles are similar, and that's going to be the key to this entire problem. And how do I know that they're similar? By the angle-angle similarity theorem. They both share this angle, and they both have 90-degree angles. So that is by angle-angle, these two triangles are similar, aka proportionate. You also have side-angle side and side-side-side similarity. And again, when we say side-angle side, it means we have two sides that are proportionate and an angle in the middle that is equal. Side-side-side similarity is all three sides are proportionate in the same way. So now we know that ABC is at least 48, but no more than 60. And we know that the base of ABC is 5 plus 7, which is 12. The height unknown, we don't know. But we know that 12 times y divided by 2, that's how we get area of a triangle, right? Base times height divided by 2 is less than 60 and greater than 48, aka 6y is less than 60 and greater than 48. Divide both sides by 6 and y is in between 10 and 8. Now, because it says y is an integer and it's got to be greater than 8 and less than 10, there's only one integer in the middle of these two that will work, and that is 9. So y has to be 9. Now we can use the fact that these triangles are similar to set up a proportion. So I know that 9 over 12, right? The ratio of the legs is going to be equal to the ratio of the legs of this little baby triangle, meaning x over 5. Now let's cross multiply and solve. 5 times 9 is 45 equals 12x. Divide both sides by 12. Let's use DESMOS and let's see what we get. 45 divided by 12 is 3.75, which means 3.75 for the win. Boom, done. Strategy 34, no more mean proportionals in right triangles. So what am I talking about here? I'm talking about any right triangle when we drop an altitude, and an altitude is where we take a line straight down from the vertex that is perpendicular to the opposite side. And what does this create? This creates 1, 2, 3 similar right triangles. Very important. Similar meaning proportionate. One other thing for this problem, this is a 3, 4, 5 special right triangle. It's something important to note. They use these nice Pythagorean triples all the time. 3, 4, 5 is the most common one, or multiples thereof, like 6, 8, 10, etc. Now, it says in the figure above, what is the length of NQ, which is this value right here. Now, as I mentioned, we've got 3 proportionate right triangles, so all we got to do is set up a proportion and we're good to go. So how do I do it? Well, if I look at this triangle here, right? I'm trying to solve for x. And what is x in this triangle? X is the little leg, okay? So we got little leg, big leg, and hypotenuse, right? And so in this little medium, or in the medium-sized triangle, we've got little leg, which is our unknown, and we got the hypotenuse. So I can say little leg over hypotenuse. And then now, if I can get little leg and hypotenuse of one of these other triangles, like definitively without x, I can solve this. I can set this up and solve it. Well, what about the big dog? I already know that the hypotenuse is 5 and the little leg is 3 right here. So now I have 3 over 5. I got a proportion. Now I can solve. Cross multiply. 3 times 4 is 12. 5 times x is 5x. Last but not least, divide by 5. And we get 12 over 5. We can use DESMOS, or we can just do it mentally. 5 goes into 12 2 times with a remainder of 2. So it's 2 and 2/5. 2/5 is 0.4, which means C is the winner. Done. Strategy number 35, always draw out a diagram. And I've been doing that for the ones where they talk about a geometric shape, but they don't give the diagram. But I just want to reiterate, so important. And I say do it every time, no matter the simplicity of the problem, so you get in that habit and you never forget. It doesn't take that much time. Length of a rectangle's diagonal. So this is a rectangle with a diagonal, so check it out. It says the length is 3 rad 17, and the length of the rectangle's shorter side, which is shown here, is 3. And it says, what is the length of the rectangle's longer side? Now that I've drawn this out, this is pretty easy. I see that this is a nice right triangle, and I'm going to solve for this little leg. So I'm going to use Pythagorean's theorem. X squared plus 3 squared, which is 9, is equal to the hypotenuse squared, which is 3 rad 17 squared. You can use DESMOS. I'm going to do it mentally though. 3 squared is 9. Square root of 17 squared is 17. 9 times 17 is 90 plus 63, right? Which is 153, is equal to x squared plus 9. Now I'm going to subtract 9 from both sides, and we got x squared is equal to 144. Beautiful, because that's a perfect square. Now we're going to square root both sides, and we get x equals technically plus or minus 12, but for a geometric figure, the negative is not going to be relevant, so we're going to go with positive 12. That's how you do it. Done. Strategy 36, know SOHCAHTOA. You gotta know SOHCAHTOA. But you don't have to know a crazy amount of trigonometry, but you do have to know this, which is sine is the opposite over the hypotenuse. Cosine is equal to the ratio of the adjacent over the hypotenuse, and tangent of an angle is equal to the opposite over adjacent leg. So check this out. In the triangle shown, what is the value of sine? So again, sine of x, which is right here, is going to be equal to the opposite leg over the hypotenuse. That's it. We're done. It's 16 over 23. That's how you do it. Done. Strategy number 37, be able to build your circle equation from scratch, right? This is in circles. Now, this is going to be really helpful, especially for a crazy abstract problem like this. And a lot of people might jump to Desmos and be like, let me use the sliders and all that. That's going to lead you into a trap, in my opinion. I think this is way better to do by hand. So check this out. A circle has a center here. Well, I know my standard equation of a circle is going to be x minus the x value of the vertex, x minus -5 is plus 5, squared plus y minus the y value of the vertex, which is 2 squared, is equal to the radius squared. 9 squared is 81. Now I've got my full-on equation of the circle, and it's going to be the same as this, because this is also purportedly the equation of the circle. And so all I got to do is multiply this out, set everything equal to 0, and then I should be able to solve for c. So let's do that now. Let's FOIL this out. This is x squared plus 10x plus 25 plus y squared minus 4y, because it's going to be -2y, -2y. So I'm kind of doing this quickly, and then plus 4 is equal to 81. Now let's get everything to the left-hand side, and I'm going to put it in that exact same format. Check this out. I'm going to rearrange it, x squared plus y squared, and then we've got plus 10x. Oh, 10x and ax, well, a is 10, not that we care, minus 4y. Oh, b must be -4. But now we want c, we want the constant. So let's add them all up. Check this out. 25, plus 4 is 29. But then I'm going to be minusing 81, right? So 29 minus 81 is going to give me -52. And then we got 0 on that side. And again, we're trying to match this constant with c, and it's right there for the taking, right? C, that constant, matches up with -52. -52 is the winner. That's how you do it. Done. Finally, we come to strategy number 38, and in circles, we would say graph circles in Desmos. This is super cool because you can do a lot of stuff with this. You can use Desmos to easily calculate the radius. You can quickly see the circle if you're not sure of things. But this is especially awesome for this problem because we're trying to figure out which one of these does not lie in the interior. And there are ways to do this pretty quickly mentally. But man, Desmos just makes it so much easier. So we can graph the circle, graph the coordinates, and see which one of these is outside the center, outside the circle. So let's do that now. So here we have the circle, and here we have all the coordinates listed out. And the only one that's outside is right here, 3, 2. So 3, 2, D is the winner. Done. That's it, guys. Those are my 38 strategies to get a perfect 800 on the digital SAT math portion. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more, make sure to click subscribe. Guys, thank you guys so much for joining. I wish you all the best of luck on your SAT math journey. Go out, knock it out, do your best, and let me know how it goes. And I will see you in the next video. Take it easy.